UCLA, and it's actually showing the buildup of Alzheimer's disease in the brain, going from normal aging to mild cognitive impairment to Alzheimer's. And you can see as the colors get more yellow and more red, that shows you where you can see these tiny little abnormal plaque and tangle deposits. Now, what's extraordinary is we can see these decades before people actually have symptoms of Alzheimer's disease, and that usually scares everyone. To me, it's cause for hope. It means that we will be able to detect things years in advance and perhaps develop a brain check where we can identify people who might respond to a prevention treatment years before they get symptoms. Now, there's also some debate as to whether the technology is making us stupid. So Carr's cover article in Atlantic was, "Is Google making us stupid?" And of course, he misspells stupid. I suppose I didn't need to point that out, but I did. Because I know some of you said there weren't any digital natives here, just in case, because it does affect their spelling. So now, what about new technology and creativity? Well, we have this accelerating pace of life that's reducing the time for thoughtful reflection. And it's ironic that the new technology was developed in part to free time up to be more creative. But there's a question. I know I'm more productive because of the technology, but there really doesn't seem to be a lot of time to sit back and think and to solve problems. And there's some debate in that area too. Others would argue that it makes us more creative because of all the wonderful things we can do with the new technology. We tried to understand some of these issues a bit better at UCLA, and we did this study, Your Brain on Google, and we wanted to see what the brain looked like the first time it searched online. And thanks to the Parvin Foundation and my collaborators there, we were able to do this study. If you're interested in it, it was published in the American Journal of Geriatric Psychiatry in 2009, at least the first part. So to find out what the brain looks like the first time it searches online, you've got to find people who have never searched online. And I quickly learned that I could not recruit them online. So I do have a rapid learning curve. So we got people like this. Congratulations, you're the first person on earth to get an email account. And we found a dozen people who were internet naive, and we matched them to a dozen who were internet savvy. And these were people in their mid-60s. They were well-educated, mostly women. And as far as we could tell, the only differences between those groups had to do with their computer and internet experience. And we used a functional MRI scanner. As we all probably know, an MRI scanner is a very narrow tube, and you can't get a computer in there. So to do the experiment, we had people wear these special goggles, and we would present them with different images. For example, we said, look at this bar and concentrate, so we could factor out what the brain does when we just concentrate on something randomly. And then we compared it to reading a book page. So we showed them a simulated book page, and then we showed them internet sites, and they had a mouse at their fingertip that they could manipulate, and so they searched online during the experiment. And this is what, first of all, we didn't find any differences between reading the information on the book or getting it online. They got the information when we gave them a test afterwards. But what was quite interesting was how their brains were responding during the mental tasks. So here the color represents where the brain is working during a particular task. And here we're seeing internet naive people reading a book page. And these colored areas are areas that control vision and memory and verbal reasoning. And that's not surprising that that would be activated during a reading experiment. Now, here's the first time they searched online. I was a little disappointed. I didn't see anything different. And I was even more disappointed when the internet savvy people read the book page. It was the same, and I thought, boy, we didn't find anything here. But then we saw this. When the internet savvy people searched online, we saw more than twofold increase in activity compared to all the other experimental protocols. So here's your brain reading a book, and here's your brain on Google. So tremendous activation throughout the brain, especially in the front part of the brain. And so part 2 of the experiment, which we'll be publishing soon, is when we took the internet naive people and we had them practice for just 1 hour a day to search online. After a week, we saw significant increases in activity in this experiment in the frontal part of the brain, the part of the brain that controls decision making and short-term memory, so holding information in your mind just long enough to make a decision. These are the kinds of mental tasks that we need when we use the internet. So what's going on? It seems a little confusing. Sometimes the brain is activated, sometimes it's not. I think what's happening is summarized here. If you look at brain activation on the vertical axis versus time, whenever we're presented with an unfamiliar task, I think there's not a lot of activity in the brain. We just don't know what to do. But once we understand how to solve the problem, there is a tremendous increase in activation. And then when we get good at the problem, there's a decrease because our brains become more efficient. We see cognitive efficiency. Now, right now, we have a lot of new developments in the field. We talk about the older brain. Michel, the CEO of Dakim, has a device, or other companies that have devices that are designed to improve brain efficiency, to improve mental tasks in an older brain because of this problem with the aging brain. And so there's a whole new market out now that wants to improve their brain and wants to improve their health as they age. This, by the way, is what I'd like to be doing when I'm 75, but I probably will not be doing it because I've never pole vaulted in my life. So genetics is important, and in fact, if you look at this generation, this is one person, my life broken down into segments, and you can see there's sleeping, working, eating, and then the big part is looking for things I had just a minute ago. So these memory challenges are affecting many people, and so we're looking for ways to improve it. One way is physical exercise, and there's a lot of evidence to support the idea that aerobic conditioning is not just good for your heart, but good for your brain. But how much? This is one person's idea of it, and I think he's underestimating it for himself. Maybe for the dog it's good enough, but basically the studies show that you need maybe 10, 15 minutes a day of brisk walking to protect your brain from aging. And I think we have an opportunity right now to innovate with the technology, to combine physical training along with brain training, because we know that brain exercises have an impact as well. We've studied this at UCLA. We did an experiment where we put people on a healthy lifestyle program for 2 weeks. It included memory exercises, physical exercise, stress reduction, and a healthy diet. And we compared them to a control group that went about their usual activity, and we found significant changes in memory as well as brain activity. Here's a woman, and she did a brain stress test at baseline. You see, she was 46. She had a lot of activity in her brain at baseline. After 2 weeks, there was very little activity, and her memory scores increased dramatically. So you see this brain efficiency. When we looked at the whole group, we saw it seemed to be focused in the prefrontal cortex. Again, the thinking brain seemed to be more efficient after just 2 weeks of healthy lifestyle. Now, to make it more personal, I know I did an experiment before. I just wanted to quickly teach you some of these memory techniques, but start out with a brain warm-up. Just say out loud what word comes to mind from the double cross. Good. Tricycle. So you kind of learn the set, your brain gets it a little better. And now those are brain exercises that are associated with better brain health. Not necessarily proven to prevent Alzheimer's disease, but associated. However, memory training has been shown to improve objective memory performance, and the studies show that you can have a sustained effect for up to 5 years. And so in our books and our programs, we try to simplify it. We use Look, Snap, Connect. So Look is a reminder to focus your attention. Snap is a reminder to create a mental snapshot of the information, to use your visual imagery to help. And Connect is a way to link the visual snapshots together so that it's meaningful and it's easy to recall later. So here's the experiment. I want you all to put away your BlackBerries and your iPhones for a moment. I caught you right there. Busted. So, and you don't know, I was just sending you a text. So, what I want you to do is use Look, Snap, Connect to remember to learn this unrelated word list, okay? So what you do is you create a story in your mind's eye, linking the words, the visual images together. It can be a logical story. It can be a silly one, just whatever works. So I'm going to read the words out loud. It can be any order, and if we have time, we'll get a volunteer at the end. Maybe we can give away a book to someone who has a good story. So here are the words. Beach, professor, horse, teddy bear